For forces and Newton's laws learning target number 2, we're looking at the difference between when the net force is balanced and unbalanced. So there's a couple things that we want to take into consideration as we start to think about this topic. First of all, just a reminder, we do want to include these words. These are our must-use vocab words. So they need to show up in our explanation, and we also need to make sure that they are color-coded. Okay, so thinking about net force, remember that's the total of all the forces acting on an object. We want to be able to know if they are balanced or unbalanced, and then how all those forces impact the object's motion. So a couple examples up here when we think about balanced versus unbalanced. Again, our goal is to think about the total net force, what those arrows look like, and then also the motion of the object. So balanced, I feel like people click with the most. Balance is another word for like even or equal. Right? So when we think about what those arrows look like, we know that they are opposite directions still, but they are equal in size. Okay? And so we can put any value on that just as a reminder that those are in fact equal. So when we think about the net force of a balanced free body diagram like this one, when we do our math and subtract to get the opposite, we're always going to get a net force of 0, no matter what, because our arrows are that equal size. In terms of motion then, because no force is essentially winning, right? There's no force bigger than the other and everything is equal. What we see here is no change in motion. And this is the important part, no change in motion. Okay? So that means the object is either at rest or moving at a constant rate. So it's just not speeding up, not slowing down. It's moving consistently because there's no one force bigger than the other. In terms of unbalanced, then, if we know all this about balanced, we can easily apply the opposite over here to unbalanced. Instead of all of our arrows being equal, we end up with arrows that are unequal. So again, we can just add some values to show that they are uneven. They're still opposite in direction, but they're different sizes. And remember, when we have unbalanced, we can also have a pair that is balanced. We've seen that a few times. So the balanced end up canceling out, and overall, we still end up unbalanced. So when we calculate our net force for this particular problem, we're looking at 40 newtons. And this one is moving to the right. So when we think in general about the net force of an unbalanced object, it's going to be any number but 0. Just anything but 0. That, of course, is letting us know that there is a change in motion to this object. So that's any kind of movement, a speed up, a slow down, a change in direction. Again, because we have that winning force, allowing that object to move in a new direction. So here, as you fill out your learning target, you're including these key words, these must-use words in your explanation, remembering to talk about all 3 of those things. Net force, what's the number that we get? What do the arrows look like in terms of direction and size? And then also, what would the motion of the object be? And because you are doing this in Notability, you know, feel free to add a drawing to your words, but that shouldn't be the only thing in your number 2.